The Great Barrier Reef is one of the world's greatest natural wonders, an intricate mosaic of corals, keys, and tropical islands. And it's an ideal location to study past climate, says paleoclimatologist Thomas Felice at University of Bremen Center for Marine Environmental Sciences. He's lead author of the study in Nature Climate Communications. He spoke via Skype.
The major aim of our expedition was to reconstruct sea level. And the Great Barrier Reef is a quite stable region in terms of tectonics of the Earth's crust. So it's far away from continental glaciers, and so it gives a good global average of sea level variations.
The expedition crew set out in the great ship Maya in 2010, equipped with a drilling rig that would extract coral fossils from the tropical Pacific Ocean that dated to the peak of the last ice age 20,000 years ago. Felice says the global sea level then was 120 meters lower than it is today.
At that time, all the ocean water was stored in the form of ice in the continental glaciers on the northern hemisphere, on Greenland and Antarctica.
But not in Australia, which was cooler than it is now and unusually dry. The crew recovered coral material for analysis at the Bremen Coral Repository in Germany.
One of our major findings is that the Great Barrier Reef, since the last ice age, experienced much larger temperature changes than previously thought.
In addition, Felice says sea surface temperatures were 2 to 3 degrees Celsius cooler along the southern Great Barrier Reef compared to the northern site they studied. By contrast, he says, that difference today is 0.6 degrees Celsius.
What we found is that these corals were quite happy. They adapted somehow to temperature changes over a period of thousands of years. However, what we experience today is that we probably will have during the next decades or 100 years temperature changes of the same magnitude. But it's important to note, these are temperature changes which will happen within just 100 years and not thousands of years.
Felice stresses that the study does not infer that today's Great Barrier Reef could easily adapt to continued rise in ocean temperature. He says it does provide a framework for understanding how the reef responded to past sea level rise and climate change to better predict future resilience.